In this video, we're going to introduce kinetic energy and explain how it relates with our current topic about work. Earlier in the unit, we discussed the definition of work and expressed it as the force times the displacement times cosine of theta, where theta is the angle between the displacement and force vector. Also, we learned that a net work can be expressed by adding all the individual work components together. In recent videos, we've been using this method to solve for the total work. However, there's a shorter way for solving these problems. But before we can get there, we must learn about kinetic energy. Kinetic energy is the energy of motion a particle possesses. Just like work, we measure kinetic energy with joules. Kinetic energy is a scalar quantity. If you recall, it means it does not depend on the direction, and this value can never be negative. Kinetic energy is expressed as 1/2 times the mass times the velocity squared. Now you may be wondering, how does this relate to work? Well, let's assume that we had an object where the net force applied was in the same direction as the displacement. If we were to write the work equation for this situation, we would have W equals FD. The reason we can get rid of our cosine of theta is because the angle between these two vectors is 0, and the cosine of 0 is equal to 1. Also, since this is a net force, we're going to be dealing with the net work done on the object. So we have to change our equation W equals FD to the net work is equal to the net force times displacement. Now, if you remember from Unit 3, we learned that Newton's second law states that the net force is equal to the mass times the acceleration. So we can use this concept and plug in mass times acceleration for the net force. So we will get the net work is equal to the mass times the acceleration times the displacement. Since the beginning of the video, you may have been wondering why I wrote this kinematic equation. Well, what we're going to do is solve for the acceleration and plug it back in to our work equation. So let me change my color and then we'll solve for the acceleration. So first, we're going to subtract the initial velocity squared on both sides. And we will get the final velocity squared minus the initial velocity squared equals 2 times the acceleration times displacement. Next, let's divide 2d on both sides. Now we can solve for our acceleration, and that will equal 1 over 2d times the final velocity squared minus the initial velocity squared. Now let's plug this in to our work equation. But first, let me change the color back to purple. So we have the net work is equal to the mass times 1 over 2d times the final velocity squared minus the initial velocity squared times the displacement. And we see that the two displacement terms cancel each other out. Let's also distribute the 1/2 m to each of the terms. So we will get that the net work equals 1/2 times the mass times the final velocity squared minus 1/2 times the mass times the initial velocity squared. And if you haven't noticed, these two terms look a lot similar to our kinetic energy we defined earlier. And actually, we can rewrite this whole equation as the net work equals the final kinetic energy minus the initial kinetic energy. And this equation is the work-energy theorem. In the next video, we'll use this theorem to solve total work when displacement or force is not given by the problem. Thank you for watching this video and hope to see you next time.